Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, lesson 1-3, entertainment expenses. Okay, example 1. Oh, before I get to that, in the box here are the vocabulary for this chapter: dispersion, range, mean deviation, mean absolute deviation, variance, and standard deviation. Okay, so now example 1 says Mrs. Maddie's video production club has 10 students in it. Okay, so let's highlight that. That is our N, if we need to do any averaging. Okay, 10 students. On the first day the club met, she asked the members how many movies they streamed last year. The 10 students reported these numbers. What is the difference between the highest and lowest number? So we don't always assume that they're in order. So notice 32, 18 is less, 15 is less than 18, and then it went up. So these numbers are just randomly ordered, and you want to look for the smallest number, which is 9. And you want to look for the largest number, which is 32, 41, 41. There's no other 40s. 3, 1, 1, 2, 2, 4, 2, 0, 4, 1, 2. So these are our two extremes. So the difference between the highest and lowest scores of a distribution is called the range. The range is never negative and can only be 0 if all the numbers are the same. So if these were all 32, and it goes from 32 to 32, 32 minus 32 is 0. And they said it cannot be negative, so you would never subtract the smallest from the biggest. So be careful, the data may not be in numerical order, as I stated already. The lowest and highest numbers are not always at the left and right ends of the list, respectively. So in order to answer this question, we want to say that the range equals X highest number minus X lowest. Okay, so that's the equation for it, or the formula, where X sub high is the highest value. So the range of this is 41 minus the lowest, which is 9. So 41 minus 9 is 32. Okay, so that was pretty simple. The range of that data set is 41 minus 9, or 32. Now it says check your understanding. Find the range for the following data set. So pause the video, see if you can do this. Come back and see how you did. Okay, here we go. So again, for starters, we are going to look for the smallest number: 8, 12, 34, 55, 68. These are in order from least to greatest. So if I showed my formula, range equals the X sub high minus X sub low ist, okay, then it would be 68 minus 8, which equals 60. Okay, fairly simple, I hope. Okay, so now we're going to extend our understanding. So let me extend my page so we can extend our understanding. How would the range of the distribution change if the number 34 was entered incorrectly and was actually a 43? So what they're saying is, what would happen if this number here was not correct and it was supposed to be 43? Would that change the range? Okay, I'm not going to write anything here, but you would say the range would not change because 34 was not the lowest or the highest, and that's the only way the range could change. Any numbers in between will not affect the range. Okay, example 2 says, Maria, a video production club member, noticed the range seemed to ignore all the numbers except the highest and lowest, like your extended exercise. Okay. She thought a better measure of dispersion. What is dispersion? There's a word I've never heard, or have I? Dispersion. In statistics, dispersion, also called variability, scatter, or spread, is the extent to which a distribution is stretched or squeezed. Okay, so how far apart all the components are if you were to plot them, or how close they are. Okay, so that's dispersion. So in other words, it's how big or small the range is, if you will. So it's very similar to range. So she thought a better measure of dispersion would be to take an average of how far each number is from the mean. So we're leading up to something here. So how far on average is each entry in the data set from example 1 from the mean of the distribution? So they gave us this in the book, but let me explain what this is. 32, 18, 15, 27, 24, 22, 9, 41, 16, 26 was just simply the values from example 1 in order. And when I say in order, they're in the same order as they were listed in example 1. They're not in order from least to greatest, okay? So what I want to do is find the average. So you're going to take this column, add it up, and divide by 10, okay? So I'm going to use a spreadsheet because it makes life easier. So I've already put those values in there. Now watch how easy it is to find the mean here. So now that I'm in this cell, I can go over to my sigma notation, which are functions, and I can take the average, which is the mean, and I can choose those cells. I think I missed it. I was off one. I missed the last one. Average. Click here, drag down to 26, let up and hit enter. And the mean, let me highlight that. The mean is 23. Okay, that is my X bar. So now I want to take, and if you look in the example here, they're saying you take X sub I, which is over here, these values from the set, and subtract them from, or subtract the mean from them. So this number minus the mean. So let's do that in the spreadsheet. So I first want to put the mean over here. So I could just say that this is going to equal this. Okay. And remember how to not change the cell. You put a $sign in front of the column name, and you put a $sign in front of the row name. And now it won't change when I copy and drag. So now if I click here and drag this down, it'll just repeat 23 over and over. Now I can click here and create a formula. In order to do that, you say equals, and I want to take X sub I, which is right here, and minus X bar, which is the mean, and hit enter. Okay. So I got 9, and it says suggested autofill. In other words, do you want to do this for all of them? And I'll say yes. So I'll go like that, and I'm going to actually delete this one. Okay, so there they are, 9, -5, -8, 4. And if I go back, 9, -5, -8, 4. That's how this column was created. Take the average of this, which was 23. And then subtract 32 minus 23, 9, 18 minus 23, -5, and so on and so on. So that's how we determined that column. So the mean is 23. The distance between each number and the mean is called the deviation. So there's another word, deviation. So how far it deviates, mean deviation. See that right there? Okay. The average of how far each number is from the mean is called the mean deviation. Set up a table and subtract the mean from each number. So that's what I just did. Okay, so these are the mean deviations. Alrighty. All right, so let's get rid of this here. So moving along, there is a formula for this, and the mean deviation uses a sum, and it can be represented algebraically. So the mean deviation equals the sum of all i's from the first I out to the nth I, and in this case there were 10, of X sub I minus X bar, all divided by n, which was 10. So if I were to fill this in for this one, let's do that. It would be the sigma notation. That was pretty bad. Let me just erase this a little bit. Sigma notation. Okay. where I equals 1, which means the first term, all the way out to the 10th term of x sub I minus the mean. So in this case, x sub I changes every time. This is x sub I, it's 32, then it was 18, then it was 15, but the mean never changed, so I could put 23 here. So we're taking all x's sub I, where I is equal to 1 all the way up to 10, and then taking that whole thing and dividing it by the number that was in the number of terms, which is 10. Okay. So there's the formula for mean deviation. You can picture each of the deviations from the mean on a number line. So if the mean was right here, which is 23, then x sub 2 minus x bar would put me here, and that was 18. So 18 is right here, and x sub 1 is 9, so 9 would go here. So the distance, so if I take 18 minus 23, I get a -5. So think of this point here, I had to go left 5 to get to 18, so that's why it's negative. To get from 23 to, oops, I put 9, it's not 9, it's 32. To get from 23 to 32, I had to go a distance of 9. There's my x sub 1 minus x bar, which is my 9 here. Okay, so hopefully that makes sense to you. You find the mean, and then every x value is on the same number line, and x sub whatever that number is minus the mean is the distance it is from that mean. So if I went and plotted x sub 3, the third term was 15, and that's -8. So that would end up here, 17, 16, 15. This would be x sub 3 at 15. And to get from 23 down to 18, I had to subtract 8. Okay, and we can do that for all of them, but it would just get really messy. Okay, so now it says check your understanding. Show that the mean deviation for the following data set is 0. Okay, so I'm going to do this in a spreadsheet. I'm going to go to my spreadsheet, and it's 8, 12, 34. So if I go here and I just copy all of these, Control C, put it over here, Control V, but now I'm going to change my values to what is in this list, 18, 12, 34. So this would be 18, 12, 34. Okay, and then I go back, and 55 and 68 are the last two. Then I'll put 55 here, 68 here, and delete the rest. Okay, so now my mean is 35 2/3. Or is it? Let me just redo that. So let me move, no, I don't have to move me. Let me go here and do average of these. And it is 35.6 repeating, which is 35 2/3. So then if I say, well, that equals this, enter, and then put a $sign here and a $sign here, and drag that down, and then get rid of these. Okay, there is my x bar, or x sub I minus my x bar column. So then we go back here, we're looking for the mean deviation. So the mean deviation is x sub 1 to n of x sub I, the sum of all those divided by the number. So now all I have to do is create a new column or a new cell here and say that that is going to equal, I want to do the sum of all of these. Okay, so that's, I don't want the equal sign, I want to hit just sum of these, and they're 0. Okay, so this is -17, -23, -1, -8, but then we have a +19 and a +32. So adding all of those up, we got 0. So it said show that the mean deviation for the following data set is 0. So to show that on paper, what you would do is you would take the sum of all these, 8. So you do 8 plus 12 plus 34 plus 55 plus 68 divided by 5. All right. And that would give you your mean, which we already did in the table. I'm not going to take time to do that. It comes out to be 35 2/3. All right. And then you're going to subtract that mean from each of these and take their sum. And that came out to be 0. All right, so now it says, let's extend the page for the extend your understanding. So now it says the mean absolute deviation requires the use of absolute value. Okay, remember what that is. The absolute value by definition is simply distance from 0. So let's just recap that real quickly. Here's 0. If I come over here to -2, the absolute value of -2 equals the distance it is from 0, and it's 1, 2. So the absolute value of -2 is 2. If I chose a value over here and called it 3, how far is that from 0? 1, 2, 3. So the absolute value of 3 is 3. So there's a quick recap of absolute value. All right. So the mean absolute deviation requires the use of the absolute value, which is more cumbersome for mathematicians to make calculations with. So it is not often used as a measure of dispersion. The negative and positive deviations used to compute the mean deviation canceled each other out. To eliminate these problems, statisticians square each deviation from the mean and find the average of these squared deviations. The resulting statistic is called the variance. Okay, and so that's our other definition from up here. Okay, variance. What is the variance? It's when you square the standard deviation. So the variance denoted sigma lowercase squared, small sigma squared, can be shown algebraically using the sigma notation. So sigma squared equals uppercase sigma. These are both sigmas, by the way. Think of a capital A and a lowercase a. This is capital sigma. This is lowercase sigma. Lowercase sigma squared equals capital sigma from I to 1 equals 1 to n of x sub I minus x bar. And we're going to take that quantity squared and divide it by n. Okay, so we're going to sum the squares. And the variance is very commonly used as a measure of dispersion. So if I go back into here, what they're saying is we want to have a new column, which would be, instead of taking, oh, actually I could, let's just do this, Control C, Control V, and put parentheses around it. Okay, and then I don't want to take the time to do this squaring, so I'll just do a caret symbol to show that we're going to square that. So now this is going to equal this squared or times itself. Okay, and then autofill. So notice they're all positive because a negative times a negative is positive. Okay, keep that in mind. All right, so now let's go back. So what did we do? We took the sum of all of those values, squared them, and then we're going to divide it by n, which was 10. So now we're going to take the sum of those. So I'm going to take the sum of these and divide them by 10. Oh, just kidding. There are only 5. 1, 2, 3, 4, 5, 6. How about 6? There are 6. Okay, so the standard deviation is 394.88. So that's the sigma squared. Now keep that in mind as well. This is squared. So now what I want to do is take the square root of that prior number And finally, we get our standard deviation of our variance of 19.87. Okay, so that's how you do variance. So we didn't use absolute value, but squaring all these values gets rid of the negatives as well. And then you take the square root of your sum, or your sum divided by your number of terms, your average of your squares, and you take the square root, and that gives you the variance. Whew. Okay, example 3 says to find the variance. Okay, so let's stop right here. The variance, remember it's lowercase sigma squared. Okay, so what do we need? We need a list of numbers. We need their sum. We need to divide that by 10 to get our average or our mean. So x bar equals 23. And then you take these numbers and subtract 23 from all of them. 32 minus 23, 9, 18 minus 23, negative 5, and so on. You add all of those values up, you get a sum of 0. You square these numbers, 9 squared, 81, negative 5 squared, 25, negative 8 squared, 64, and so on. You add those all up and you divide by 10. That will give us 76.6. So there is our variance. Okay, it's actually pretty simple once you do a couple of them. So in this exercise, it said, or in the example, sigma squared equals the sum from 1 to n of x sub I minus x bar quantity squared, all divided by n. So we got 766 when we squared all those values and added them up. Divide by 10 and you get 76.6. The variance is 76.6. Your graphing calculator has a menu option that can find the variance if you input the data. Consult the manual to see how it's done on your specific calculator, but I will show you now how to do it on a Texas Instruments calculator, TI-83, TI-84, 84 plus, CE, any one of those. This is how you do it. So turn your calculator on, obviously. And I like to clear everything before I get started. I go to y equals or something there, I clear it. I make sure my plot is off, they're not on, and I go to stat. So the first thing we do after everything's clear is click stat right here. Number 1 is edit. That's where we want to be. So we just hit enter. L1 means what are we going to put in column 1? Well, we're going to put these numbers in L1. So it's going to start with 32 and then 18, 15, 27, 24, 22, 9, 41, 16, 26. Okay, whoops, 26. Cancel. Arrow back. I can't hit the left arrow. 26. Enter. Okay, 41, 16, 26. See where it says L1 parentheses 11? That means that that's the next blank. So that means there's 10 filled and there are 10. So we're good. Okay, just want to verify you typed them in all correctly. So once I do that, we're done. The calculator will do everything now. All we have to do now is click stat. See this calc right here? Arrow over to it. We only have one variable, okay? X sub I. There's no X comma Y here. It's not two variables. So it's one variable. So we're going to use 1. Hit enter. And it's asking where to take the list from, and it's already designated L1, and that's where I put my data. Frequency list, just leave blank. Get down to calculate, hit enter, and it calculates it. The mean, or x bar, is 23, right there, 23. The sum of all the x's is 230, that's right there. You take the sum and square them, and you get 6,056. We aren't using this information. Capital S of x is 9.22. We're not going to use that right now. Here is ours. Sigma x equals 8.75 2142595. Okay. Now notice that is sigma. We want sigma squared, so we would want to square that. All right. So 8 squared is 64, and 8.7 squared, 8.75 squared. If I went to my home screen, I could do 8.75 squared, and that would give me 76.56, which rounds to 76.6. Okay, so let me go back. calculate, enter, 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 and there's more. See this arrow here? N equals 10 tells us how many were in our set. Go down one, the minimum was 9. That is right here. It tells us our minimum. Quartile 1 is 16. That's if we're doing box plots. The median is 23. Quartile 3, again with box plots, is 27. The maximum 41. All right, so it tells us everything we need to know, but we had to square this. We want sigma squared. So the variance is 76.6. All right. Now check your understanding. Cell phones morphed from a discretionary expense to an essential expense over the past 2 decades. The following data set shows the number of new cell phones owned by students at Cold Spring High School during the first 5 months of the school year. Find the variance for this data set round to the nearest hundredth. Okay, so I'm just going to do this in the calculator. So I'm going to go in here and I'm going to clear. I'm going to go to stat. I'm going to go to edit. I'm going to arrow up to L1 and hit clear and arrow down and then it'll be gone. I will type these 5 numbers in: 11, 13, 15, 28, 30. Okay, that's it. Stat, calculate, 1 variable statistics and just enter through there. And there's all my data. Oops, I hit the clear button here. So I'm gonna go back. Stat, calc, 1, 2, 3, 4. All right. So I will just write everything down here. Let me get my pen. I'll use red. Bring this back up. And how about I do this? All right. So X bar equals 19.4. That's the mean. N was 10. Sigma X was, that's really bad sigma. I struggle with writing that. I do not write good sigmas. Okay, sigma sub X equals 7.9649. I'll just go out 4 decimal places. So I want, let's try that again. I want sigma squared. So then I'm going to go to my home screen and put 7.9649 squared, enter, and I get 63.44. Oh, is that right? Stat, edit, okay. Stat, calculate, 1, 2, 3, 4. My N is not 10, by the way, it's 5. That's why I went, oh, so 19.4, sigma is 7.96, so the sigma squared is 63.44. Okay, so I got, let's do this manually here. So I'm going to say sigma, let's just check this, sigma squared equals the sum of all of these. So X sub I, all of these, 11 plus 13 is 24, and 15 is 39, and 28 is 49, 59, 67, and 3 is 97. So we're going to take the sum of all of those values, 97, divided by 5, and that's the mean, and that would be 19.4. So then we're going to take, how about we do this in the spreadsheet? Okay, 11, 13, 15. So I will clear all this. I'll put 11, 13, 15. Okay, and then what else? 28, 30. 28, enter, 30, enter. So there's my 19.4 mean right here. I don't need these, so let's get rid of them. All right, so there's my 19.4. That's my average. My N is 5. So now what do I need to do? I need to square this column. So then I'm going to take this column here and square it. I'm not going to put a header just for time's sake. And it's going to equal this times itself. That's the same as squared. and autofill. All right, take the sum of those and we get 317.2. Okay, so we took the sum of all of those squares and then we divide by 5. So then we say that equals this divided by 5, enter. I got 63.44 and it checks. Okay, so there is the variance for these values. Okay, standard deviation. So I'm going to read this before we continue. It says, since the variance squares the deviations from the mean, the units of variance also must be squared. So if a problem's original units are hours, the units of the variance are hours squared. If the units are movies, the units of the variance are movies squared. If the units of it are dollars, the units of the variance are also dollars squared. These squared measurements don't make much sense. To measure dispersion using the original units of the problem, statisticians take the square root of the variance to form a measure of dispersion called the standard deviation. The standard deviation is probably the most common used measure of dispersion. Okay, I think I did actually misspeak back there and I said the variance was the square root. It's not, that's the standard deviation. The square root of the variance is the standard deviation. Okay, so example 4 says, find the standard deviation for the data from example 1. So if I go back here, here is our data here. Oh, from example 1, they said, okay, let's go back here then. And so the solution would be, in example 3, the variance for the data from example 1 was found to be 76.6 movies squared. To find the standard deviation, all we have to do is take the square root of the variance. So the standard deviation, so let me go back to that. So right here, if the standard deviation, or if the variance is sigma squared, and you take the square root of sigma squared to get the standard deviation, then the standard deviation is the square root of sigma squared. So it'd be the square root of all of this. So it'd be the square root of all this here, which would give you the square root of 76.6. Okay. And that's what all we have to do here. So the square root of 76.6 is approximately 8.75. And notice now the movies are not squared. Okay, because if you take the square root of movie squared, you get movies. Notice how the units are movies, the original units of the example. You can describe this distribution as having a mean of 23 and a standard deviation of 8.75. You do more interpretation of the standard deviation in sections 1.4. So I'm not going to say any more about it here. Okay, so now we're going to check your understanding. It says find the standard deviation for the following data set by filling in the columns in the table and using the formula round to the nearest hundredth. Pause the video, see if you can find the standard deviation to this, and we'll come back in a moment and see how you did. Okay, so I'm assuming you did this, so let's take a look. So if I take 11 plus 13 plus 15 plus 28 plus 30, that will give me X bar. That's the first thing we do, X bar. Okay. So 30 and 28 is 58, 68, 73, 83, 86, 96, 97 divided by 5. So the mean is 97 divided by 5. So the mean is 1, 9, and I think we already did this, 19 point something. Let's just save time and go back and look. Got 19 point something somewhere. I know I did. I remember that number. Anyway. Let's just do this then. Oh, there it is, 19.4. 0.4. All right. So then 11 minus 19.4. And if you wanted to show all your work, then you would do this. 11 minus 19.4 and get negative 8.4. let me just do this. 13 minus 19.4 is negative 6.4. And 15 minus 19.4 would be negative 3.4. And 28 minus 19.4 is 8.6. I think. Let me make sure I don't make any mistakes. 28 minus 19.4, 8.6. And 15 minus 19.4, negative 4.4. Good thing I checked that. This is a 4. And then finally, 30 minus 19.4 is 10.6. So then we're going to square those. And I'm going to ignore the negative, so I don't have to type it in, because a negative 8.4 squared is the same as 8.4 squared. We're going to get positive every time. So this is going to be 70.56. This is going to be 6.4 squared, which is 40.96. 4.4 squared is 19.36. 28 or 8.6 squared. Did we do that yet? No. 8.6 squared. Enter. 73.96. And then finally 10.6 squared is 112.36. Okay. All right. So what does the formula say we have to do? We take the sum of all those values squared. So now I'm going to add all those up. 70. Whoops. Let's try typing over here first. 70.56 plus 40.96 plus 19.36 plus 73.96 plus 112.36. Enter. I got 317.2. Okay, that is the sum of those values squared. Then I'm going to divide those by 1, 2, 3, 4, 5. So if I hit divide 5, enter, that gives me 63.44. Okay, so now I want to take the square root of that. So this, remember, is sigma squared equals, let's put this over here. Sigma squared equals that 63.44. And if I take the square root of it, that's going to give me the standard deviation, which is just simply sigma. And that is the square root of the last answer. Enter, and it's 7.96. And the unit of measurement is movies. Well, it doesn't say what this is, so just 7.96. Okay. Let's do it with the calculator now. Stat, edit, 11, 13, 15, 28, 30. There it is. It's already in the calculator. And then I do stat, calculate, one variable statistics, enter through, and there it is. Standard, or the standard deviation is 7.96. And there it is right there. So all you have to do is enter those in your calculator under stats and calculate it, and it does it all for you. Okay, pizza. That look good. All right, pizza is a very popular discretionary expense for high school students. The table below shows the number of times the 80 seniors at Smithtown South High School visited Smithtown Pizza Pals in August. Find the standard deviation and round to the nearest hundredth. I love the names. All right. So we want the standard deviation. Okay, so they gave us number of visits 5, 10, 12, 14, 16, 17. Frequency F of students with this many visits 12, 21, 8, 18, 15, 6, 80. All right, so it says solution. Since there is more than one senior for a given number of visits, you need to take a frequency into account. The mean is 12 visits during August. To find the standard deviation, set up table columns as shown on the next page, and I brought that in right here. So here's what we're going to do. We're going to do number of visits and frequency F, which what they gave us. And then what they did was they took X sub I times F. So it's just this times this. 5 times 12, 60. 10 times 21 is 210, etc., etc. Okay. And then they added all of these up and they got 80. They added all of the frequencies times the number of visits up and got 960. Okay, so 960 divided by 80, 960 divided by 80 is 12. Okay. So our average, our X bar equals 12. Okay, so I'm going to put that over here. X bar, our mean, is 12. So notice this is -7. 5 minus 12, -7. 10 minus 12, -2. 12 minus 12, 0. 8, 14 minus 12, 2. 16 minus 12, 4. 17 minus 12, 5. So this column here is the difference between the number of visits and the average number of visits. Then they square them. -7 squared is 49. -2 squared is 4. 0 squared, 2 squared, 4 squared, 5 squared. Then we're going to multiply that squared by the frequency, 12. 12 times 49, 588. 21 times 4, 84. 8 times 0, 0, and so on. Okay, so let's recap what happened. Number of visits, frequency they occurred, and then found X sub I times F, divided and got the mean, subtracted each number of visits from the mean, or the mean from the X number of visits, I should say, and then squared that, and then multiplied that by the frequency. Okay, you tracking? All right, so then we're going to use this formula, which is the mean is the sum of all X sub I F sub I, which is this column here, 960. Okay, so I'll just write that in here. 960, that was this column here, X sub I F. They just called it F sub I, whatever. And then N was 80. And that's what gave us 12. All right. And then we take this, and the standard deviation is the sum of all of the squareds times the frequency. The sum of them, which is 1,134. They did that for us. So this is going to equal the square root of 1,134 divided by 80. And that is going to equal our standard deviation. So then if I go into my calculator, I'm going to check this in stat edit. Okay, and I'm going to use this column here to continue. So if I go enter and I arrow up and clear that, start fresh. Okay, I want this column added up. Let me make sure that's right. X sub I minus X bar, X sub I minus X bar. We want, let's minimize this. We want the sum of X sub I minus X bar squared times F of K. F sub K. All over N. So let's just do the square root. Okay, the square root of 1,134 divided by 80. and we got the standard deviation of 3.76. And that should be that is a approximation. All right. Okay, so the standard deviation is 3.76. So the mean was 12, and each standard deviation was 3.76 away from that 12. Okay, so what I did was I brought in my x sub i's. I did it in a spreadsheet. The frequencies here, and then if I just click in this cell, it says A2 times B2. So it's 5 times 12. A2, B2, 5 times 12, 60. And then I just dragged that down, and that gave me the x sub I times f for all of these, which is the number of visits, frequency, or number of visits times the frequency. And then I took the sum of f and got 80. I took the sum of x sub I times f and got 960. And this 12 was C8 divided by B8. So C8 is 960, B8 is 80. That gave me my x bar, or my mean. So then I came over here and said, okay, see my formula? A sub 2 minus $B $9, which means always use this cell, never change. But the A2 will change to A3, A4, A5, A6, A7. And I drag that down, and this is the difference of 5 minus 12, negative 7, 10 minus 12, negative 2, and so on. Squaring that gave me negative 7 squared is 49, negative 2 squared is 4, 0 squared, 2 squared, 4 squared, 5 squared is 25. Then you multiply that by the frequency again, and I get these numbers, and there's their sum. This is the standard deviation, which is the square root of this sum divided by the frequency 80, n, okay? And that is this right here. All righty, now check your understanding. Donations to charity are discretionary expenses. In a class of 30 students, 6 students donated $5 each to Relay for Life. 15 students donated $10 and 9 students donated $20 each. Find the standard deviation for this distribution, round to the nearest hundredth. Okay, pause the video, see if you can do this, come back and see how you did. Okay, so here's what we do. If we're going to have a column and we call it x sub I, that is going to be our dollar amount donated. Okay, so x sub I is our dollar amount donated. And there was $5 donated, $10 donated, and $20 donated. Okay, our frequency is how many students donated that amount. 6 students donated $5, 15 students donated 10, and 9 students donated 20. And that's how we start. And we're just going to keep going, but I did it in the spreadsheets to save time. So let me bring that over here. Okay, so there's the $5, $10, $20, 6 students, $5, 15 students, $10, 9 students, 20. I took x sub I, which is the dollar amount, times the frequency. That gave me $30. So if 6 people donate $5 each, that's $30, $150, $180, totaling $360. Divided by 30, which is the number of students, and my average is 12. Okay, so there's my mean, x bar. Then you take x sub I minus 12. 5 minus 12, negative 7. 10 minus 12, negative 2. 20 minus 12, 8. Square them, 49, 4, and 64. Multiply the squared values times f. 6 times 49, 294. 15 times 4, 60. 9 times 64, 576. You take their sum, which is in F5, and you divide it by B5, which is 30, our n, and take the square root. So I have square root of 930 divided by 30, and the standard deviation is $5.57.